Hello children, welcome to Math Part. Today we are going to start with the new topic, Chapter 12, Midpoint Theorem and its Converse, and the application-based questions based on that from the book Concise Selena Class 9 ICSE. So this exercise is going to be solved in two parts. So we start with the first question today. And children, when we are solving these questions and if you understand it, if you like the video, you should please share with your friends. And if you are new to the channel, please subscribe. So we start with the first question. In triangle ABC, M is the midpoint of AB and a straight line through M and parallel to BC cuts AC in N. Find the length of AN and MN if BC is equal to 7 centimeter and AC is equal to 5 centimeter. Now, we know two theorems, midpoint theorem and its converse. Now, this question is based on the converse of midpoint theorem. So, it says that if a line is drawn parallel from the midpoint of one side of a triangle and parallel to another side, it bisects the third side. So since M is the midpoint of AB and MN is parallel to BC, so by converse of midpoint theorem, we get N is the midpoint of AC. Okay. So this is what is the converse of theorem, that is midpoint theorem. That is line drawn to the midpoint of one side. This is the midpoint given. Okay. Parallel to the second side. It bisects the third side. So this is how you get N is the midpoint of AC. Now you are given the BC value is given as 7 centimeter, right? So BC, so you have MN. Now by midpoint theorem, you have MN. M is the midpoint of AB and N is the midpoint of AC. So line segment joining the two midpoints by midpoint theorem, it says that this MN, which is parallel to the BC and also is half of it. So you have MN is equal to half BC, which is half of 7, that is 3.5 centimeter. Okay. Then AN, you have to find AN. Now AN is equal to half of AC because N is the midpoint and AC is given as 5 centimeter. That is how you get AN is equal to 2.5 centimeter. Got it? Question number 2, prove that the figure formed by joining the midpoints of the adjacent sides of a rectangle is the rhombus. So you are given a rectangle ABCD and PQRS are the midpoints of AB, BC, DC and AD respectively, right? So you have to prove that PQRS is a rhombus. So rhombus is a quadrilateral which has all the sides of equal length. It is a special parallelogram, right? So what do? We will now draw the diagonals AC and BD, okay? Now the diagonals are equal. We know that the properties of a rectangle, that the diagonals of rectangle are equal. So AC is one of the diagonal and BD is another diagonal. Now, in triangle ABD, BD is the diagonal. And by midpoint theorem, you know that the S is the midpoint and P is the midpoint of AB. So, line segment joining the midpoint of two sides of a triangle is parallel to the third side and it's half of it. So, this is how you get PS is half of BD and PS is parallel to BD. Okay. So, same way you will get PQ, this QR will also be parallel to BD and QR is equal to half BD. This is how you get PS is equal to QR. Got it? So, similarly, we can have the triangles based on diagonal AC. So, in triangle ABC and triangle ADC again, you will have PQ will be parallel to AC and PQ is equal to half AC. Also, SR will be parallel to AC and SR is equal to half AC. And this is how you get PQ is equal to SR. Now, both the pairs of opposite sides are parallel, also equal. Then you get PQRS is a parallelogram, right? Now, PQRS is a parallelogram, but we know that the diagonals of rectangle are equal. So, this PS is equal to QR, which is equal to BD. So, from this, since you have BD is equal to AC, you get all the sides equal and therefore PQRS becomes a rhombus. When the adjacent sides of a parallelogram are only equal, we can say that it is a rhombus. Here we have proved that all sides of the parallelogram are equal. That is how it is a rhombus. Question number 3, D, E and F are the midpoints of sides AB, BC and CA of an isosceles triangle ABC, in which AB is equal to BC. So, these two AB and BC are given equal. You have to prove that DEF is also an isosceles triangle. So let us start with the given isosceles triangle where AB is equal to AC. Now AB is equal to AC, and also you are given that D and E are the midpoints. So D, E, F are the midpoints of AB, BC and CA respectively. So by midpoint theorem, you get DF. This DF is equal to half of BC and EF is equal to half of AB. So DF is equal to half of BC and EF is equal to half of AB. But we know that AB is equal to BC. So therefore, you get DF is equal to EF. Now, when we know that two sides of a triangle are equal, then it becomes an isosceles triangle. This is how we have proved that DEF is an isosceles triangle. Question number 4. In the following figure, you are given a trapezium ABCD in which you are given AB is parallel to DC and P is the midpoint of AD. Okay, and in triangle ABD, you are given that P is the midpoint of AB and PQ, which is a part of PR, is parallel to AB. Therefore, by converse of midpoint theorem, you get Q is the midpoint of AB. You get Q is the midpoint of DB. Sorry, Q is the midpoint of DB, right? So now, if Q is the midpoint, we can use the in triangle BCD, we again use the midpoint theorem. You know that Q is the midpoint of DB and you know that QR is also parallel to DC. Okay, this PR, which is QR, is the part of PR. So PR is parallel to DC. That is how a line drawn through the midpoint of one side parallel to the another side biases the third. This is how you get R is the midpoint of BC. So we proved that R is the midpoint of BC. Now further, in triangle ABD, you get PQ is equal to half AB. So that is how you get this 2 moves here. You get 2 PQ is equal to AB, right? In triangle BCD now, you get QR is equal to half DC or half CD. That is how you get 2 QR is equal to CD. Okay. Now, if we add these two equations, you get 2 PQ plus 2 QR. You get 2 PQ plus 2 QR is equal to AB plus CD. Taking 2 common, 2 in bracket PQ plus QR is equal to AB plus CD. But PQ plus QR is nothing but PR. PQ plus QR is nothing but PR. That is how you get 2 PR is equal to AB plus CD. This 2 moves over here. So you get PR is equal to half of AB plus CD. So this is how we have done with question number 4. Got it? Question number 5, we have again a trapezium ABCD. And in this, M and N are the midpoints of non-parallel sides, AD and BC. Find Mn if AB is equal to 11 and DC is equal to 8 centimeter. Okay, so this is to be done in the parts. So let us join AC now. So let us join AC. So now here in the first part, let us do the first part. AB is given as 11. This AB is given as 11 centimeter. Okay. And DC is given as 8 centimeter. So we know that M is the midpoint and we know that these three lines are parallel to each other. So that is how by converse of midpoint theorem, let us write here O. So you have OM. This we have in triangle ADC, we have OM by midpoint theorem is equal to half of DC. So you get OM is equal to half of DC, which is given as 8. This is equal to 4 centimeter. Correct? Same way in triangle BCA or in triangle ABC, you are ON. N is the midpoint and this line is given as parallel. So by converse of midpoint theorem, you get this line's parallel and you get O as the midpoint. Since O is the midpoint now, you can have ON is equal to half of AB and ON is equal to half of AB. AB is given as 11. So which is equal to 11 divided by 2, which is 5.5 centimeter. And that is how you get MN is equal to OM plus ON, which is equal to 4 plus 5.5, which is 9.5 centimeter. Got it? By converse of midpoint theorem, we have O is the midpoint of AC. And now let us start with the second part. In the second part, you are given DC is given as 20 centimeter and MN is given as 27 centimeter. MN is given as 27 centimeter. You are asked to find AB. Okay, we are asked to find AB. So in triangle ADC, you have OM is equal to half of DC. So which is equal to half of 20, that is 2 ones are and 2 tens are. We get this as 10 centimeter. And you are given Mn is equal to 27. So you get On is equal to 27 minus 10, which is equal to 17 centimeter. You get this as 17 centimeter. Now in triangle ABC, you have On is equal to half of AB, or you get AB is equal to this 2 moves here twice ON. Now ON we have already calculated, which is 17. So 2 times 17, which is equal to 34 centimeter is your AB. So AB is 34 centimeter. We are done with second part. The third part, you have to find DC when you are given MN is equal to 15 centimeter and AB is equal to 23 centimeter. So if I take triangle ABC, so you have in triangle ABC, you get ON is equal to half of AB, which is equal to half of 23, which is 11.5 centimeter. We got this as 11.5 centimeter. Now we are asked to find DC. So we know this is as ON as 11.5 centimeter. Now you know that MN is given to us MN is given to us 15 centimeter in the third part. So you get OM is equal to MN minus ON, which is 15 minus 11.5, which is equal to 3.5 centimeter. We got this as 3.5 OM, we got 3.5 centimeter. So now let us use the midpoint theorem for triangle ADC. So in triangle ADC, now you have OM is equal to half of DC, or DC is equal to twice OM. So which is equal to 2 times 3.5, which is 7 centimeter. Got it? This is how we got DC as 7 centimeter. The diagonals of a quadrilateral intersect at right angle. So you are given a quadrilateral ABCD where the diagonals AC and BD intersect at right angles. You have to prove that the figure obtained by joining the midpoints of the adjacent sides of a quadrilateral is rectangle. So this means in this you are given a quadrilateral ABCD. So ABCD where P is midpoint of AB, Q is midpoint of BC, R is midpoint of DC, and S is midpoint of AD. And diagonals AC and BD intersect at point O. We have to prove that PQRS is a rectangle. So rectangle is a special parallelogram. So we'll first try to prove it as a parallelogram. So in triangle ABC and triangle ADC, we are now looking for two triangles which are based on diagonal AC. So by midpoint theorem, you get PQ is equal to half AC, and same way SR is equal to half AC. So that is how you get twice PQ is equal to AC and PQ is parallel to AC. Same way you get RS is also parallel to AC and you get 2RS is equal to AC, right? So this we got from equation number 1 and 2. You have got twice of PQ is AC and twice of SR is AC. Now let us use the triangles on diagonal BD. So in the triangles, in this diagonal BD now, so we will be looking for the triangles based on this diagonal BD. So first of all, from this equation number 1 and 2, you are already getting that PQ is equal to RS and PQ parallel RS. So we got, since only one pair of opposite sides parallel and equal, we can say it is a parallelogram. But we can have the another pair also. When we look at triangle ADB, P is the midpoint and S is the midpoint. So you are getting PS is going to be double of BD, and same way QR is also going to be double of BD. So that is how you get PS is equal to QR, or PS is equal to RQ, and PS parallel RQ. So therefore you get PQRS. Since both the pairs of opposite sides are parallel and equal, you get PQRS is a parallelogram. Now the target is to prove it is a rectangle. So children, for proving a parallelogram to be a rectangle, we just have to prove one angle of a parallelogram as a right angle. It becomes a rectangle. Why? Because in a parallelogram, we know that opposite angles are equal. So if this is going to be 90 degree, the other, this one is also, P is going to be 90 degree. The condition for a parallelogram to be a rectangle, simply proving one angle as a right angle is enough. So we have angle AOD. This angle AOD is equal to angle 1 because these are corresponding angles. Since we have BD, we have BD is parallel to QR. Okay, BD is parallel to QR, and you have this AC as a transversal. So this is how you get angle AOD is equal to angle 1 as corresponding angles. They are right angles. But angle 1 is equal to angle this Q, RQP. So this is again 90 degree. Why? Because again you have AC is parallel to PQ. Okay, and therefore these two are again corresponding angles. So this is how one angle we got a right angle. So we can say it is a rectangle. But in the similar way, we are able to prove all of these as right angles. The way we have proved angle Q as 90 degree. This is how you get PQRS is a rectangle. Got it? So first thing is we need to prove it is a parallelogram. Secondly, we need to prove one angle to be right angle. Moving to question number 7. L and M are the midpoints of sides AB and DC respectively. So L is the midpoint and M is the midpoint of DC. You have to prove that DL and BM trisect diagonal AC. That means we need to prove all the parts. This is AP is equal to PQ is equal to QC. This is what we need to prove. Okay. So let us use now BL is equal to DM. BL is equal to DM. Why? Because opposite sides of parallelogram are equal. So AB is equal to DC. So half AB is equal to half DC. So half AB is nothing but BL and half of DC is nothing but DM. So this and BL is parallel to DM. Therefore, you get BLDM is a parallelogram. So first thing we proved this is a parallelogram now. Now we have BM. Since it is a parallelogram, both the pairs of opposite sides are parallel then. So we have BM is also parallel to DL. Okay. Now BM is parallel to DL. Now in triangle ABQ. In triangle ABQ. Let us look for this triangle ABQ and use the midpoint theorem for that. ABQ. We are talking of this triangle ABQ. L is the midpoint of AB and PL. This PL is parallel to BQ because opposite sides of parallelogram are so opposite sides of a parallelogram are parallel. Correct. So therefore, by converse of midpoint theorem, you get P is the midpoint. You get the P as the midpoint of AQ. So this is how you get then AP is equal to PQ. You've got AP is equal to PQ. Right. Then next, by in triangle CDP again, M is already the midpoint and these are parallel. So therefore, you get Q becomes the midpoint of CP. If Q becomes the midpoint, then you get CQ is equal to PQ. Got it? M was the midpoint of DC and a line drawn parallel through one side of a triangle, okay, to the another. It from the midpoint bisects the third side. That is how you get Q as a midpoint. So you get CQ is equal to PQ. So from this equation 1 and equation 2, what you understand, both are equal to PQ. So you get AP is equal to PQ is equal to CQ. And AC is made up of all these three. So AC is equal to all of this. That is how you get AC is equal to AP plus PQ plus CQ. And that is how you can say that the diagonal DL and BM trisect the diagonal AC of a parallelogram ABCD. They make three equal parts of a diagonal AC. Got it? You are given a quadrilateral ABCD where E is the midpoint of AB, E is the midpoint of AB. Okay. Then you have F is the midpoint of diagonal BD. F is the midpoint of diagonal BD. G is the midpoint of this side. Okay, DC. And H is the midpoint of diagonal AC. You have to prove EFGH. EFGH is a rhombus, right? So let us start with the given part. So we have AD is equal to BC. First of all, you are given that AD is equal to BC. The first part. Secondly, in triangle ADC, in triangle ADC and triangle ABD, what do you have? You have GH. Look, in triangle ADC, GH, this triangle, GH, G is the midpoint, okay? And H is the midpoint. So line segment joining the midpoint. Line segment joining the midpoint is parallel to the third side and is half of it. So you have GH is equal to half of AD. So that is how AD is equal to twice GH. Same way in triangle ABD again, you have E is the midpoint of AB and H is the midpoint of AC. So that is how you get EF. Sorry, F is the midpoint of BD. So that is how you get EF is also parallel to AD and EF is equal to half AD. So this is how you get twice of EF is equal to AD. So from this you get 2EF is equal to 2GH which is equal to AD. Let this be our equation number 2. Next, moving to the another triangle. So now we are looking for the triangle with the base where one of the sides is BC, right? So in triangle BCD, you have G is the midpoint of DC and F is the midpoint of BD. So from this, you will have GF will be parallel to BC and GF is equal to half BC. So if GF is equal to half BC, you get twice GF is equal to BC. Same way in triangle ABC. In triangle ABC again, when we look at triangle ABC, you have, see in triangle ABC, you have E is the midpoint of AB and H is the midpoint of AC. That is how you get EH is parallel to BC and EH is equal to half BC. So this is how you get twice EH is equal to BC. Right? So from this equation, you get 2GF is equal to 2EH. And that is equal to BC. That is our equation number 3. So what you understand from these three equations? You get 2GH is equal to 2EH is equal to 2EF. GH is equal to EF, right? So we get all these four parts we get equal from this equation 1, 2 and 3. Why? Because all of those are equal to AD and BC. And since AD and BC are equal, we get these parts equal. So this is how you get GH is equal to EF is equal to GF is equal to EH. So we get this all the sides of the quadrilateral equal and therefore you get EFGH is a rhombus. Got it? Question number 9. In a parallelogram ABCD has P is the midpoint of DC and Q is the point on AC such that CQ is equal to 1/4 of AC. And PQ produced meets BC at R. You have to prove that R is the midpoint of BC. Right? So let us take the diagonal BD and the diagonals of a parallelogram bisect each other. So let us say they are bisecting at say point X. Okay. So this is how you get AX is equal to CX and you get DX is equal to BX. These two parts you get equal because diagonals of a parallelogram bisect each other. Now you are given CQ is equal to 1/4 of AC. CQ, this is given. CQ is equal to 1/4 of AC is given to us. But what is AC? AC is nothing but twice CX. Can 2 1s are 2 and 2 2s are 4. So you get CQ is equal to half CX. So this is how you get Q is the midpoint of CX. So if Q is the midpoint of CX, you get CQ is equal to CX, right? So CQ is equal to half CX, so you get Q is the midpoint. So you get CQ is equal to CX. Now in triangle CDX, this triangle, you have PQ is parallel to DX and because PR is parallel to BD, right? So in CBX, you have Q is the midpoint of CX and QR is parallel to BX. So therefore you get R is the midpoint because QR was parallel to BD. So by converse of midpoint theorem, you get R is the midpoint. Q, we already proved the midpoint, right? And you know that QR is parallel to BD. So therefore, you get R. By converse of midpoint theorem, you get R is the midpoint of PC. So we are done with the first part. Secondly, you have to prove that PR is equal to half DB. Now in triangle BCD, P and R are the midpoints of midpoints of CD and BC respectively. Therefore, by midpoint theorem, you get PR is parallel to BD and PR is equal to half BD and that's it. That is how you got PR is equal to half BD. Got it? So this is how we completed with the 9 questions of this exercise. Remaining questions we'll be doing in the second part of this video. So if you like the video, please share with your friends. Thank you for watching. Have a good day.